everybody. Welcome to lesson number 7. In lesson 7, we're going to look at part 1 is going to be sketching and part 2 is going to be specifications. So let's get started. Every time we start lesson 7 with sketching, I always hear people say, but I can't draw, or I'm not going to be able to do this. I can't draw. You know what? I really can't draw freehand either. The point of sketching, though, isn't to create a work of art. The point of sketching is to be able to get your ideas across. Sketches are a great way to share your ideas. You can add additional views to existing drawings. They're quick and easy. You can do them anywhere. You just need some paper and a pencil. And they're an excellent tool for brainstorming. Some other tools you can use for sketching. You can get a set of pencils that have different lead weights in them. You can get pens that have different tip thicknesses. We can use scales, rulers, compasses for our circles, set squares and protractors for angles, templates. You can buy templates for all kinds of different things, furniture, symbols. You could set up a drafting board, and you could use a T-square. All your sketches are going to be made up of 4 types of lines: vertical, horizontal, diagonal, or curved. And each of those lines will have 2 qualities: their width and their depth, or how dark they are. All your sketches can start out with basic shapes. Once you have your basic shapes, then you can start adding details to it. So shading helps to give it the illusion of form. Here we have a little piece in the top left corner we want drawn. It'd be very hard to try to draw this if you began drawing it down in the corner and moving around. By the time you got over here, things would be out of sorts probably. It's easiest just to start out with your basic shapes, like we have here. Again, this is a terrible tool for drawing with, excuse me. But start out with your basic shapes, then start taking bits and pieces away from it, adding more details as you go along until you end up with your finished sketch. In lesson 7, we're going to talk about something called pictorial drawings. All along, we've been using orthographic drawings, so just 2D views of a part. In pictorial drawings, they show objects as they appear in real life. They're going to show your length, your width, and your height. And they're going to look 3D. We have 3 types of pictorial drawings: an oblique, an isometric, and a perspective. And we'll get into the differences between these. So in our pictorial drawings, we want to see length, width, and height. So we want to see all 3 axes: your X, your Y, and your Z. Figure 2 started out with a photograph of a bread box, and then they created 3 pictorial views: isometric, oblique, and perspective. At first glance they look similar, but you can tell right away that each one is different. Let's take a look at what makes these different from each other. So let's look at the isometric drawing. An isometric drawing always has a corner facing you. From there, your lines go 30 degrees from the axis, and all your other lines are parallel to the ones that you began with. So these are always 30 degrees from your axis. An oblique drawing has the front view facing you. You always start out with the actual front view. Then your receding lines go back at whatever angle you choose. It's usually about a 45-degree angle, but again, your receding lines are all parallel to each other. So the oblique drawing always shows our front view. A perspective drawing looks somewhat similar to the isometric. However, in a perspective drawing, we use something called vanishing points. So they've given us a side view of the part here. So we start out with one view. But then the receding lines, if we were to look at these, if these kept going, this isn't a good tool again, sorry for getting straight lines, but if these kept going, they would all meet in the back someplace at what's called a vanishing point. So an isometric, the corner faces you and the lines go back 30 degrees. An oblique has the front view facing you, and a perspective uses vanishing points. So here's an example of a perspective drawing using the vanishing points. Here is an oblique drawing. In this oblique drawing, there's two types of obliques. So they've started out with the front view. So in both of them, we have our front view. And let's say this toolbox is 16 inches long. So in the Cavalier, they've actually drawn these lines 16 inches long. In the cabinet view, they take that and they cut it in half. So they've actually only drawn the lines 8 inches long. So the Cavalier view, it kind of gives you a bit of a distorted view. It doesn't really look like it's supposed to, but the dimensions are true. In a cabinet, it looks more realistic, but the dimensions aren't true. They're half of what they should be for the receding length. And here we have an example of the isometric. So again, the corner faces you, and then your lines on the X and Y axis go back 30 degrees. So this is your isometric axis. So if you had an orthographic drawing, a front view, a top view, and a right side view, if you put them together to form your isometric drawing, this is what you would end up with. You could look at it from the left or the right, but let's take a look here. So this would have been our front view, this would have been our right side view, and this would have been developed from our top view. You can use a T-square with set squares on them to get your angles. You can use a 30, 60, 90 triangle. And this is just figure 14 shows you the actual development of the box. So they started out with their corner, they went back 30 degrees, and then the other lines are all parallel to the first ones. And that's what your completed isometric sketch would look like. Isometrics are the most common ones. They're the easiest to draw. Perspectives look more realistic, but they take a lot more time. So in your workbook or your handouts, you have a couple of drawing exercises to try. I'm going to walk you through this first one, and again, I apologize that the drawing tools aren't very good, but hopefully we'll get an idea. So we're going to start with our front view. And we're going to start in this corner, and we're going to create our isometric sketch. So if we look, this shape is 1, 2, 3, 4, 5, 6, 7 blocks long. So 1, 2, 3, 4, 5, 6, 7. 7 blocks long. So we'll connect that. And then we know that it's 1, 2, 3 blocks high. So let's go up 3 blocks. 1, 2, 3. This face is 1, 2, 3, 4 blocks long. So let's come back 4. 1, 3, and 4. This step is 2 blocks high. Let's go down 2 blocks. This face is 1 block high, so up, and then we'll connect it. Our top view, again, it's 1, 2, 3 blocks deep. So 1, 2, 3. We knew that this line is 4 blocks long. And they'll be connected. This step comes down 2. Sorry, it's hard to see this color on the screen. And then the next step comes back 3. Our edges get connected, down 1, and our edges connect. So if we looked, our right side view would be what we see here and what we see here. So go ahead, pause the video and give it a try. I'm going to show you a couple more of them and the answers will be included. Okay, so after you're finished of your sketches, if you wanted to, you could add your dimensions to them. When you add dimensions to pictorials, it's easiest to use unidirectional dimensioning. If we were using a CAD program or adding a lot of details, we would use hatching or section lines to show the different materials. So remember, when we're doing sketching and looking at pictorial views, how something appears is just a matter of perspective. So part 2 of lesson 7, we're going to talk about specifications. A specification is an explicit set of requirements to be satisfied by a material, product, or service. Should a material, product, or service fail to meet one or more of the applicable specifications, it may be referred to as being out of specification, and the abbreviation OOS may be used. Specifications contain information not shown on your plans. It's usually telling you how to perform the work and what materials you'll need. They're usually in a separate book. Unless it's a small project, then they could be included on a drawing sheet. They're generally divided into 16 divisions. If it's a really large set, they might include plumbing as a separate one outside of mechanical. Administration, legal, and technical provisions are covered in Division 1, which is general. So that's who's responsible for what, your timelines, financial things. Then Divisions 2 through 16 or 17 include specific information for each area pertaining to the project. So for instance, if we looked at Section 16, or Division 16, we'd see that Division 16 would be electrical. Some of the other divisions, I don't remember all the numbers off the top of my head, but for instance, there would be one that would be metals. Remember that your specifications are a contractual part of your project. If you make something and it meets 99 out of the 100 requirements of the specification, you still need to meet that last one requirement, or else it will be out of specification. So when we have specifications, we said we have 16 main divisions. Then underneath that, we have sections. And underneath that, we have subsections. And they can keep adding as many subsections, letters, or numbers as needed. So you have drawings and you have specifications. What happens if there's something conflicts between them all? In that case, we have to know the hierarchy of which one takes precedence. So in order of what you follow, right at the very, very top is your code. If it was electrical, it's your electrical code. Underneath that, we have the project specifications. Below that are addendums or revisions that have been issued. Below that are shop drawings, so things that you go out and physically buy, such as the windows, doors, hardware, anything that you've bought. And at the very bottom of it all are your actual blueprints. So your specifications overrule your blueprints. So that takes us to the end of the introduction. Okay, bye everyone. See you next lesson.